brain. I was gonna say my brain. My head, my freaking hair is. Shit. My hair is so bad, but I don't give a hell. I don't know. I just want to record this video for me to like just be explaining what I just learned on this first chapter of physics book that I'm reading, that I'm learning from, that I'm studying. It's called Giancoli Physics from Giancoli. That's the name of the author. And yeah, I'm just starting to like learn physics. You know, I just read a insane prompt to Grok, just talking about it. I'm just gonna like talk about that, right? So like from chapter one, because as you can see from the chapters, they're like how much chapters there are. There are 32 chapters from physics, and right now I just finished this one. It took me nearly 1 month of just 1 hour a day. You know, some days I missed like 3 or 4 days, so it's realistically, you know, like less than 31 days, right? Um, I don't know, like 26 days. Um, and yeah, so how much hours is that? So 31, let's say 5 days, 26 times 1.2, let's say 31 hours. So I spent roughly 31 hours approximately into this chapter because, like, you know, even when I was like skimming through the book, I was like, through the textbook, I was like, man, this I'm gonna do it in like 3 days. But nah, like my objective here is to build that, you know, understanding, not just memorizing and bullshit. Cause like memorizing is just bullshit. It's really not great. You know, I really like the idea of a semantic tree for learning anything, like literally a semantic tree. So semantic tree for learning anything. By the way, you also have it here. So yeah, I like this analogy a lot, and also just makes sense. I haven't really investigated if it actually makes sense on like the physics of our brain and neurons and how it works. It just makes sense to me. Yeah, and for a lot of people too, right? Like also Elon Musk has said this. He's not like some average dude out there, so you know, basically this is about ignore the text, like I don't know what it says, but the trunk is like the most fundamental parts of any knowledge that you have, right? So in the case of physics, the most foundational from in this case will be motion, right? Or kinematics, what they call kinematics, motion, like how things move, right? Like how these things moves, how I'm moving, how the earth is moving, how the earth is moving uh, around the sun and all that. That's basically it, how things move, how stuff moves. Then you have dynamics or forces, you know, which is basically why things move, right? Like why this is moving, why am I moving, why the earth is moving, rotating, sorry, and then why the earth is um, moving around the sun. Why? In that case, obviously it's gravity, but you know, there's more to that. There's more to that. So why things move, which is really interesting. And then, um, you know, I think that's like one of the foundations. Also, another one is energy. So energy, basically, in all the universe, like energy. You know how energy transfers for example here how the energy is transferring from my hand from my body to this pen, and then how the energy, you know, transfers from the sun to earth. I don't know, like just energy in general, how energy transfers and stays conserved. So those are like the three main like foundations of physics from my opinion, and um, things just make sense, right? So I'm gonna be focusing on that first, which also it's it makes sense because the author, which is clearly really good physicist, because his book is really like popular and whatever, has done this, right? So first is motion, kinematics, then kinematics. Then you have gravitation, which is how things move, or sorry, why things move. Then you got into energy, momentum. I assume is the same, like motion. We're still in motion. Okay, this is another thing, but basically this is like also the base, right? From motion and forces, and that's basically the trunk, right? And then the leaves and the branches and whatever are things that build on top of that knowledge, which in this case are things like, I assume this one, elasticity and fracture, fluids, oscillation and waves, sound, temporary and kinetic theory, heat, thermodynamics, electricity, electric charge, electric field, electric potential, electric currents, DC currents, direct current circuits, sorry, magnetism, electromagnetic induction, electromagnetic waves, light, the way nature of light, optical instruments, the special theory of relativity. And you start to get into these parts of current physics, obviously, because physics is just a lot of shit. Sorry, a lot of beautiful shit. I didn't mean that to in the mean way. Um, so yeah, that's just what I'm gonna do right now. Like, I'm just gonna be for the next months, like just building this trunk, and with a focus on understanding. Cause yeah, I could easily just read, like in I don't know 3 months all of this, right? But like if I just read, I'm not gonna understand, right? So for example, in here, I was just like questioning, okay, why is this? But what is the usefulness? Oh, what the fuck? And that's just what I'm gonna do with everything in order to like really understand it. Because understanding, I really value, in my opinion, more understanding than memorizing. Memorizing it is a thing from the past, and at the end of the day, understanding is just keying. It's king. It's fucking king. It just makes sense. So I'm just gonna do that. And from the first chapter, which was basically about measurements, how we measure stuff. It's literally all about measurements, as it says right here. Measurements, right? General introduction to physics, also. So yeah, key takeaways was first physics as a field. You know, I basically put this prompt just answering to the prompt, but yeah, let's see. You nailed big picture physics in the final answer, but the least wrong knowledge we have, spanning from atoms to the universe, drives innovation like Musk, SpaceX rockets, aligning with your vision to create impact. Yeah, this is very personalized. A little bit my fucking whole life into it. That's why it says vision to create impact. So I just want to create impact, man. I think that's cool, and I think this is a life worth living. So yeah, positive impact, obviously, because there are some people in history that have made some impact, not in the best interest of humanity, as if we can say that way. Um, yeah. So physically, like, this is a really cool thing about physics, which is not trying to say I'm right, but rather trying to say I'm less wrong, and I just love that. I love that. I just love that about physics and science in general because it basically gives you the whole fucking window to keep growing, to keep getting better, to keep acquiring knowledge, to keep questioning it, to keep just infinite fucking progress. And I just love that. So yeah, that's what I got from this part of the book, which is basically the nature of science. Yes, literally talking about that nature of science. For example, they give an example of who was this guy? I don't remember the names honestly, but it was fuck, I forgot his name. Oh my god, I cannot believe I forgot this guy. This guy's like famous and shit. Okay, it was Copernicus, but then this was also another guy. Okay, so here it says Ptolemy geocentric view of the universe. A. Ah, yeah, it was Ptolemy. How do you say this? Ptolemy. Ptolemy, bro. English is not my first language for now, so I don't know how you say this in English. Translator. Pronunciation. Ptolemy. 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 How do you say it?
Ptolemy.
Ptolemy. What?
Ptolemy.
Okay. Ptolemy. Okay, so, so you have Ptolemy, which said, oh, Earth is the center of the universe, or, you know, the universe back then, it was like the solar system, right? Or at least in their minds. And then freaking Copernicus came and said, you're fucking wrong. The sun is the center of the universe, or in this case, of the solar system. He was right. It's kind of crazy. That was like 1 year. Copernicus, where this the 1400s. That's crazy. 14 to 1500s. And yeah, this is just a beautiful thing about physics, right? So you just keep questioning, 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 and even the things that we have know now, probably 100 decade, no, 1 decade, not like 1 century from now, is gonna just be redefined, and just all to be less wrong. And I just love that. Relation to other fields, yeah, basically like physics is the mother of all fields, of all sciences, like the foundation. We go back to this thing, physics is here, physics is the law, and then everything builds from there, basically. That's pretty interesting. What else? Okay, so yeah, then we got into significant figures, which I said it was rounding to the least principal measurement to stay true to your calculations. I just define it as staying true to yourself based on the calculations accuracy. Like you have a certain uncertainty, that's very interesting. Like that's just true. Yeah, it's not like every measurement or calculation that we make is going to be exactly that way. Like with the current measurement tools that we have a lot of uncertainty, right? Obviously, some measurement tools have greater uncertainty than others, but we still have uncertainty, so we need to take that into account in order to obviously stay true to the actual like calculate measurement. So here, well, significant figure is just about that, right? So round to the least precise measurement to stay true to your calculations accuracy. Like for example, this one, and you have um, figures, significant figures, meter more uncertainty, whatever. Uncertainty, spot on. Every measurement tool has physical limits. Rule of thumb, yeah, that's just a rule of thumb. Percentage uncertainty, yeah, just in a percentage way. Example calculation. Like I'm just skimming through it because I literally wrote this with my freaking hands, and I've 10 fucking. Well, from here, I just did it with dictation. This was pure hacks. I just want to go through this, like, yeah. Models, theories, and laws. This is very interesting because, one seems, yeah, it's just very interesting. Basically, models are simplified representations of very complex stuff that our brains or monkey brains cannot comprehend. It's just like, oh, here's a representation to just understand it, right? Like the solar system model, exactly. Like solar system reality is like crazy fucking big, and we just use these models to fucking represent it, and it's just like, oh, okay. Then theories. These, well, here he defines it as educated guesses with some evidence but not fully proven, like string theory. That string theory is very interesting. But yes, it says it's a theory. It's not like something that is, hey, this is the least wrong thing we have come up with. Yeah. string theory. String theory is the theoretical framework in which the point like particles of particle physics are replaced by one dimensional objects called strings. That's very interesting. String theory describes how the strings propagate through space and interact with each other on distance scales larger than the string scale. A string acts like a particle with mass, charge, and other properties determined by vibrational state of the string. In string theory, one of the many vibrational states of the string corresponds to the graviton, a quantum mechanical particle that carries gravitational force. Thus, string theory is the theory of quantum gravity. Yeah. This is like very high level physics, so I just don't understand for now, but it's closest to reality based on current knowledge, thus laws. So basically, it's literally close to reality, as it says. Newton's laws. Units, standards, and SI system. This is very interesting. It was very interesting because throughout history, we have all had humanity. Like, for example, in France, they had a way to measure stuff. It's like, hey, this is how you measure a meter or whatever. It was a stick, a metal stick. And, there was a point in history, I think in Europe or in France, where each one had a different way of measuring something. Some people were like, oh, the length of this guy's arm, that's gonna be a meter. It's like, bro, it just was chaos. So he gradually progressed. Then, all the friends, I think, agreed to like a stick or something that was much better, less chaos. And then it just kept improving till we got to the SI system, which is very interesting because it's not about the stick. Like, it's about things from the universe, or in general, in order to have the same measurement and not have chaos in the universe. So if someone is in Mars, they can agree to the same system of measuring stuff that we have here on Earth. That's just prevent less chaos. That's just better in general. So yeah, as it says, using it to measure quantities relative to standards. So the SI system, which has the following standards: the meter, it has 7 currently: meter, kilogram, second, ampere, Kelvin, mole, and candela. Meter obviously for length, kilogram is for mass, second is for time, ampere is for electrical current, Kelvin is for temperature, mole is for like just amount of stuff in somewhere, and candela is for light intensity. So yeah, this is universal global consensus in causing measurements. For example, the meter is based on the speed of light. That's interesting. I didn't knew that until now. So yeah, that just little makes it usable anywhere in the universe, and that's great. Converting units. Yep, it's about switching between units. That's basically it. It's literally converting units from meters to seconds, from miles to hours, and that's just essential, right? Order of magnitude. It's rapid estimating, simplifying big numbers, and giving approximations to understand scale, like the piano toner problem. Great for quick checks and estimates. Then dimensional analysis. This one's interesting because, like, as I said, it's basically about breaking equations into SI dimensions. So it ties back to this SI system stuff. So we have equations. I mean, it can be used for other things other than equations, but it's generally used, or at least from what I asked, the internet is generally used in equations, just to break down equations into its most like fundamental truths, which are like the SI dimensions or SI systems. Like, for example, here is length, time, mass, to check if they're likely true. So, for example, if an equation gives like both t, or in this case time, they're true. If it gives like t and then t squared is false. True, false, in reality, like, it's just less wrong or more likely to be wrong, right? Because it's just not an absolute answer, but whatever. Yeah, it's a BS detector based on current physics, basically. So yeah, that's basically the chapter 1. It was very interesting. Significant figures. Their length. So significant figures reflect precision measurement, which relates to uncertainty. Applies uncertainty of 0.1. Okay, you mentioned converting length to time. Time to light intensity. That's not quite right. Okay, Unit compression is within the same physical quantity. Oh, okay. Length of time happens in equations. Okay, I understand. Why chapter 1 matters. Physics foundation. Measurements are how we translate the universe into human terms. That's literally it. As you've said, without them, no physics. No physics. Okay, what the fuck? Touch AI. Okay, yeah, this is based on something that I gave it to him. Bro, this is no longer available right now. He wouldn't understand, but whatever. Chapter 2. What's next? Yeah, chapter 2 is like, at the end of that, I'm just gonna do a little bit of practice of chapter 1, just like, I don't know, 1 week, less than 1 week, like, just to, like, understand it really, really deeply, and then I'm gonna go for chapter 2, motion. We actually start to get to the physics, right? But this was like just necessary. Yeah, it's gonna be interesting. How things move, yeah, how stuff moves. So yeah, that's it. I just wanted to like document this thing. Bye bye.